So we have a practice test here. It's kind of funky right here. I first messed up on the instructions. It should say for 1, 2, and 3 above. I just said 1, 2, but it's 3. We need to identify what's going on. So let's describe the way they describe end behavior. When we did it in chapter 5, I described it as x approaches something, f of x approaches something, right? Right here it's backwards. So I'm going to leave it the way the final exam is going to give it. So the final exam is also going to talk about your y values first, and then they mention your x values. So let's understand. Go ahead and pick any option. A, B, C, D, E, F. Pick one. I mean, not F. A, B, C, or D? Or E? C. All right, let's take a look at C. It says the end behavior, the graph, it says the graph y, the y values of the graph are going where? Up or down? Down. The y values are going down when you look at it how? To the right or to the left? This means to the left as x approaches negative infinity. Your x values are left and right at negative infinities to the left. So you got to know how to read this. It's saying that your graph goes down as you look at it to the left. Okay, let's look at which one. Which graph goes down as you look at it to the left?
2 and 3.
2 and 3. All right. So we're testing option C here. And then it says your y's, your graph goes up as you look at it where? To the left or to the right? To the right. So which one of these go up to the right? Both of them. So far C could work for either 2 or 3. Okay. The next fact, it's an odd degree polynomial. Well, odd degree polynomials have an end behavior, one down here, one up here. You could never have both up here or both down here, because if you had both up here, that would be 2, which means even, or down here, 2 would be even. So both of these are odd, so that didn't help me either. The last fact, the function has 3 real zeros. 1, 2, 3. This one obviously has 1, 2, 3, 4, 5. So which is your correct answer? 3. All right, so C belongs to 3. C belongs to 3. Okay, how about pick another? I don't know. A. A says the end behavior of a graph is f of x, f of x goes to positive infinity as x approaches positive infinity. So what does this really mean? It says the graph goes up to positive infinity as you look at it where? To the right. Okay, so this one goes up as you go to the right. This one also goes up as you go to the right. Let's keep reading. The y values go to positive infinity as you look at it how? To the left. The graph goes up as you look at it to the left. This one goes down as you look at it to the left. This one goes up as you look at it to the left. So far, option A might belong to number 1. And then we say it's an even degree polynomial function. Does it have both arrows up or either both arrows down? Yeah, both arrows up. So definitely it's even. How many answers does it have? This says this function has 4 real zeros. Does it have 4 real zeros? 1, 2, 3, 4. There we go. A belongs to number 1. And now we need to find 2. So again, when you have a multiple choice test, you don't have to just think about everything. You could look at your answers and try to identify the easiest ones that will eliminate the answer. So for example, which is easy, how many real answers it has? How many real zeros it has? So how many real zeros does number 2 have?
5.
Has 5, right? 1, 2, 3, 4, 5. Okay, so which one says 5 real zeros? 4 real zeros? None of those. So what do we say? F. Pretty easy, right? It looks complicated, but it's not that bad. Let's move on. All of these will be multiple choice on tomorrow's test. Right now, only some of them are. But you need to show your work, all right? I'll give you some space to show your work. You have to show your work. If you don't have the correct work, if you just have a bunch of gibberish, that's not good enough to give you points as a correct answer, even if you have the right multiple choice answer, right? I need to see some correct work. So number 4, we need a factor, and what factoring method are we going to use? You can't pull out a GCF. What could we do? I hope you guys remember sum of 2 cubes. Sum of 2 cubes. A cubed plus B cubed equals a binomial A plus B times a trinomial a squared minus ab plus b squared. The binomial will be the same binomial without the cubes. And if it was a plus, this middle term is going to be a minus. So the question is, could we rewrite number 4 as something cubed in parentheses plus something cubed in parentheses? That way we could identify the a and the b. So what value cubed will give us 64x cubed? 8? 4? Okay, what about the x though? You need 4x, right? 4 and x. 4x times 4x is 16x squared times another 4x will give you the 64x to the cube, or cubed, not to the cubed. Anyway, the other parentheses is going to have what? 5 and y. So now we've identified our a value and our b value, which means we could jump right into the binomial times the trinomial. Okay? I always say that the binomial, just write it, the same binomial without the cubes. So what are we going to put right here?
4x plus 5.
4x plus 5. And,
5y.
I'm sorry. And over here on the trinomial, I always say use parentheses. We'll do one with parentheses and one we'll try to do it in our heads. Or should we try to do this one in our heads together? Parentheses, okay. So we're going to put a squared. If the first binomial was plus, what's the middle term going to be? Minus a times b, and then at the very end plus b squared. So our a value is 4x, our b value is 5y, and all we have to do is simplify that trinomial. The trinomial will be 4x squared. 4x times 4x is 16x squared. The middle term will be a minus. 4 times 5 is 20. X times y is xy. And the 5y times 5y, that's plus 25y squared. So which is the correct answer? We don't, oh no, this is a minus sign. We need a plus sign, so that didn't work. The b value works? Does the b value work? D. See, this plus 20 is supposed to be a minus 20. So be very careful. It is D. Now you might have both of them. You'd circle both. Right here you only have one. Number 5. This is a difference of 2 cubes. Difference of 2 cubes. Okay? The difference of 2 cubes formula, a cubed minus b cubed equals the binomial a minus b times the trinomial a squared plus ab plus b squared. Sorry, that's pretty ugly. But anyway, could we identify what values belong inside the parentheses? What cubed will give you 27x cubed? 3x. Perfect. What cubed will give you an 8? 2. So we've identified our a and our b. So let's now jump right to our binomial times the trinomial factored form of that difference of 2 cubes. And right here, I want to try to do it without parentheses, and just to see how you feel about it. So what's my first binomial going to be?
3x minus 2.
Yeah, 3x minus 2, erase the cubes, so 3x minus 2 goes right in there. And over here, I know I have a squared, right? A is 3x. So imagine 3x in parentheses. What is 3x in parentheses squared? 9x squared, right? 3x times 3x is 9x squared. If it was a minus, what's this going to be? A plus. Now, imagine, I'm not going to do it, but imagine, parentheses, you put the 3x times 2. What's 3x times 2? 6x. So if you do it carefully, you could do it without parentheses. But if you're kind of risking it, if you're kind of scared, just do it with parentheses. Last but not least, we have plus b squared. So you really have plus 2 in parentheses squared. 2 squared is what? 4. See, we're done. So which is the correct answer there? A, B, C, or D? E, none of these. None of them checked out. Number 6. There's 2 ways of doing number 6. I want to explain both. You could select whichever way you want. So one way is to do difference of 2 cubes, identifying that you could put x in the parentheses. This is a minus sign. And you could put what in the parentheses on this one? 4, right? 4 times 4 times 4 is 64. So I could write it as a binomial times a trinomial. What belongs in the first binomial? X minus 4. What belongs in the trinomial? A squared, which is x squared, plus a times b. What is x times 4? A times b? 4x. And last but not least, what's b squared right here? What's b squared? 16. So I rewrote this to look like this, and I'm going to divide it by this binomial x minus 4. So if I were to divide it by x minus 4, guess what? The x minus 4's cancel, and we have our answer right there. That's one way of doing it, using the difference of 2 cubes. The other way is simply dividing one polynomial by the binomial, which you could use long division. I guess there's 3 ways. You could use long division or synthetic division. I love synthetic division. Check it out. We're going to put what in the box? 4, positive 4, right? And then we have the coefficients. What are the coefficients? And you have to represent every single power. 1 on the x to the 3rd, 0 on the x squared, 0 on the x, negative 64 is the constant. So when you go down, you combine 1 plus nothing is 1. As you go up, you multiply. 4 times 1 is 4. As you go down, you combine. 0 plus 4 is 4. As you go up, you multiply. 4 times 4 is 16. As you go down, you combine. 0 plus 16 is 16. As you go up, you multiply. 4 times 16 is 64. And what happens here? Remainder 0. That's great. So what's our answer going to be? It's your depressed polynomial, which is simply 1x squared plus 4x plus 16. Same exact quadratic trinomial as before. So you have 2 options, or actually 3 if you want to do long division, which I don't recommend. That takes a lot longer. But you could use the formula of difference of 2 squares to cancel out the binomial, or you could use synthetic division. You choose. Number 7 is just a basic factoring question. We should all be good at this by now. What's the first type of factoring you should try? GCF. What could you pull out of there? 2. Bless you. Okay, what would be left on the inside? 3a squared plus 1a minus 4. I didn't have to put the 1. I just put the 1 there. Now, could I continue factoring on the inside? Well, unfortunately, there's a 3 right here, which means it's not going to be simple. I need to try that long method of multiplying a times c. So let's all begin by putting step 1, a times c. 3 times negative 4, that's negative 12. That is the answer for step 1. Step 2 is to think of the multiples of that number, negative 12, that combine together to give you the middle value b. So let's make a list. 1 times 12. Negative 2 times 6, negative 3 times 4. Which pair of numbers combines together to give us the middle value, positive 1? 3 and 4. Negative 3 and 4. We don't have to do any sign changes. We're ready to rock. Step 3 is to plug it into your factored form format, but it's kind of weird because you have an ax in the front of in the first part of the binomial, and also an ax in the first part of the binomial. Now, we don't even have x's here, it's a's, but my a value is 3. Be careful, don't go back to the original and put 6a, that would be incorrect. Remember, we're doing the blue one, the 2 we factored out. So put the 3a in both positions right here. 3a, 3a. I want to erase that. Oh, whatever, I'll just leave the ax right there. And what happens to these blank spots right here? The minus 3 and the positive 4 go right in there. So put a minus 3, positive 4 right in there. And step 4 is to magically reduce each binomial by the GCF. So the first parenthesis, what could you divide both of those by? By 3, what do you get? Okay, and what could you divide the other one by? Nothing. So 3a plus 4. Ladies and gentlemen, this is, oh wait, I'm sorry, I forgot the 2 out here in the front. 2 in the front times a minus 1 times 3a plus 4. That's completely factored right there. So on your multiple choice answers, I'm probably going to say which one of these is a factor. And if you see the 2 and you see the a minus 1 and you see the 3a plus 4, circle all of them. If you don't see any of them, put none of these. If you only see one of them, circle one of them, so on and so on.
So 2 by 2 is a factor.
So 2 is also a factor. Yeah, you factored out that 2. Number 8, what kind of factoring are we going to do on this guy? You can pull out, well, you can't pull out a GCF from the whole thing.
Or you have to do 2 groups.
Yeah, the 2 groups. We're going to factor by grouping, so let's do that. The first group will be x squared minus xy. The second group will be 3x minus 3y. In the first group, what could I pull out?
X.
X. What would I have left on the inside?
X minus y.
X minus y. Okay, in the second group, what could I pull out?
3.
3, a positive 3. And what will be left on the inside?
X minus y.
X minus y. That's a good thing. We have the same binomial here, same binomial over here, which means we could pull out that common binomial from both groups. So I'm going to put some exaggerated parentheses here. I want to pull out that common binomial, x minus y. And what do I have left on the inside? I have this x, I have this 3. So I have an x plus 3. There's your answer, x minus y times x plus 3. We factored it. Pretty easy if you know all these different factoring methods. Let's move on to the back side. On the back side, they give you a polynomial and one of its factors, and they want you to find the remaining factors. So they tell us this polynomial, this cubic polynomial, and they tell us that x minus 3 is a factor. So when you know that something's a factor of something else, if you divide something by one of its factors, you get no remainder. You get 0 as a remainder, right? 4 is a factor of 12. If you divide 12 by 4, the answer is 3. There's no remainder. It works out perfectly. So I could do synthetic division. What do I plug into my box?
3.
A 3, the opposite of what you see here. Why? Because if you set it equal to 0, if it is a factor, you would end up setting it equal to 0. When you do zero product property and you solve it, you'd get x equals 3. That's why we're plugging in a 3, not a negative 3. Anyway, what are the coefficients? 1, negative 1, negative 5, negative 3. No missing values. It's great. The 1 comes down. 3 times 1 is 3. And then combine the negative 1 plus 3. What do you get? 2. Multiply 3 times 2. What do you get? What is, when you combine negative 5 plus 6? 1. When you combine, or when you multiply 3 times 1? 3. And of course, when we combine at the end, we get 0. There's no surprise there because they told us that this is a factor. We better get 0. Okay? If not, we did something wrong. Anyway, why did I do this? Because these numbers right here are my depressed polynomial. Okay? So once I get to a quadratic, once I get to an x squared polynomial, like this is a constant, this is x squared. Once I get there, I'm going to write it as a quadratic. 1x squared plus 2x plus 1. Now the question is, could I factor that? It's a standard form quadratic trinomial with the a value of 1. Let's try it. What times what is 1 that if I combine together is 2?
1 times 1.
Yeah, 1 times 1. There it is. We completely factored it. The original that they gave us, the x minus 3, they gave us that. And the 2 other ones that we found were x plus 1 and x plus 1. If this would have been a question like solve it, right? Like solve this equation, then you would set it equal to 0, split them all up. You get 3 answers, positive 3, negative 1, and negative 1, which technically those are the same answers. Anyways, right here they wanted us to factor which one is the correct answer.
So is it D?
It's just D. Just D right there on number 9. Number 10. Same process. What are we going to plug in inside of the box? A negative 1. Give me the coefficients, please. 1, 4, negative 7, Negative 10. Just make sure there's no missing values with the powers. As you come down, 1 plus nothing is 1. As you go up, negative 1 times 1, that's negative 1. As you go down, 4 take away 1 is 3. As you go up, negative 1 times 3 is negative 3. As you go down, negative 7 plus negative 3, negative 10. As you go up, negative 1 times negative 10, positive 10. Remainder 0, no surprise. Why? Because they gave us a factor. This is a factor, which means that when you divide it, you get 0 as a remainder. Anyway, let's write our depressed polynomial because there's a quadratic here already. X squared plus 3x minus 10. I need to factor it. Hopefully I could. What times what is negative 10 that if I combine together is a middle value, positive 3? Negative 2 times positive 5. Doesn't matter which one you put where. Positive 5 and negative 2 are the correct numbers that go in there. So the correct answer is just D. X minus 2 is right there, D, but there is no x plus 5. So just D. Jumping to number 11. So right here, guys, I'll be honest with you, these could get crazy. If you have a graphing calculator, it's awesome, or the Desmos app, it's awesome. Why? Because you type in y equals this junk, and you could see your graph and identify where it crosses, and you'll be able to see where it crosses. So like, let's say this one was the answer. You would see it cross at negative 1 and at negative 4, but you still have to do some math to find your imaginary values, right? But the Desmos app or the graphing calculator really helps out. You could just graph it, and wherever it crosses the x-axis, those are going to be real answers. Now let's say we don't use the graphing calculator, and let's say this is the final exam right here, or actually tomorrow, if I don't use the Desmos app, what would be a good guess? Like, we could go through and say, okay, rational root theorem says that the multiples of 8, all the multiples of 8 over the multiples of 1 are going to be our possible answers, right? So what kind of possible answers do we have? We have 1, and we have 2. We have, is 3 a possible answer? No. 4? And what else? 8. And all those numbers but negative. Because remember, the P over R is a plus or minus, which means it could be positive, it could be negative. So you could have negative 1, negative 2, negative 4, negative 8 as well. So you have a total of 8 answers to test. That could take all hour, right? So let's look at our multiple choice answers and see which real answers repeat the most. Would it be smart to plug in an 8? Heck no, none of them have 8. So which one do you think would be good to start with? 1? Negative 1's even better, right? Because look, there's only one of them that has positive 1. There's 3 of them that have negative 1. So the smart thing to do would be plug in that negative 1. And could somebody read me the coefficients? 1, 4, negative 3, negative 14, negative 8. We're good. And let's start doing this. 1 comes down. 1 plus 0 is 1. Negative 1 times 1 is negative 1. 4 and negative 1 is 3. Negative 1 times 3 is negative 3. Negative 3 and negative 3, negative 6. Negative 1 times negative 6, positive 6. Negative 14 and positive 6, negative 8. And negative 1 times negative 8, positive 8, which means the remainder is 0. So we guessed right, this does work. Now, we have the right answer, negative 1, but we need more answers. So it could be, so far, option B, option C, or option D. Which other number would you like to test? 2? 2? All right, let's try 2. So since I know this worked, I want to use these coefficients now instead of the original. You could go back to the original, but I want to use the depressed coefficients right now. So let me write wait, you guys want to test what? 2. Okay, so let's put the coefficients of the depressed one. 1 3, negative 6, negative 8. So as you go down, you combine. As you go up, you multiply. As you go down, you combine. As you go up, you multiply. As you go down, you combine. As you go up, you multiply. It worked. Now at this point, instead of testing more numbers, I want to jump right to the quadratic, because this is the constant, this is x squared. I know how to deal with quadratic trinomials. Some of them are super easy. What times what is 4? That if you combine together is 5. A positive 1 times a positive 4. So I've factored it. Now I'm factoring it, but I need to solve it because they're actually wanting answers here. So x plus 1 has to be equal to 0. X plus 4 has to be equal to 0. X equals negative 1. X equals negative 4. So what answers did we get? We got x equals negative 1. We got x equals 2. We also got negative 1 and negative 4. So which is the correct one? B. Let's jump to number 12. Which number would you like to plug in? See, this number is big. I mean, think about the possible answers. It could be 1, could be 2, could be 4, could be 5, could be, what else? 10, could be 20, and it could be all those negative. That's a long list of the numbers to be just randomly guessing. Look at the answers and see which number would be a good one to start guessing with.
Negative 2.
Okay, let's try negative 2. Let's put the coefficients. Give me the coefficients of number 12. 1, 0, 6x, oh, 6, why did I put an x? And 20, constant 20. 1 comes down, that's 1. Negative 2 times 1 is negative 2. 0 minus 2 is negative 2. Negative 2 times negative 2 is positive 4. 6 plus 4 is 10. Negative 2 times 10 is negative 20. And yep, our educated guess worked out great because we got the remainder 0. Now I'll put x squared minus 2x plus 10 equal to 0. Whenever I get to a quadratic, I usually write it out because I know how to solve quadratics by factoring. And even if it's not factorable, I could use a quadratic formula to find those answers. But in this case, it is factorable. What times what is 10 that if you combine together is negative 2? Oh, garbage. I lied, it's not factorable. So we have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And then when you use it, please use parentheses to replace those variables before plugging in your actual values. And let's identify our a value is 1, our b value is negative 2, and our c value is 10. So the b value is negative 2, goes right in there and right in there. The a value of 1 goes down here and up here, and the c value of 10 goes right over here. Now, you start with the discriminant value, the value inside of the root. What is negative 2 squared?
4.
Okay, what's 4 times 1 times 10? 4 times 1 is 4, times 10 is 40. So you really have 4 take away 40, right? What is 4 take away 40? Negative 36. So we have the plus minus in the front, the positive 2 out here, and 2 times 1 is 2. Everybody with me? Now, the square root of negative 36, what is that? 6i. I6, but you have to multiply them and you get 6i. So 2 plus or minus 6i over 2. Now we should know that whenever you have two terms that you're adding or subtracting for that matter, if they're divided by a single number or by a monomial even, you could split the monomial to each to divide them. So you could say this division of 2 could be right here, 2 divided by 2 and 6 divided by 2. So you have 1 plus or minus 3i. Or you could reduce all three terms by 2. Reduce by 2, reduce by 2, reduce by 2. 1 plus or minus 3i. You don't have to put it over 1, but there's your answer. So it is C, the correct answer. We got the answer negative 2 working because we got the remainder 0. And we also have 1 plus or minus 3i. Right here, 1 plus or minus 3i. These are not that bad. Listen up, guys. they give you two answers, one real, one imaginary, and they want you to find the polynomial that the answers came from. So it's kind of like working the entire thing backwards. Let's write down our answers. X equals -3. And also x equals -5i. And yesterday we learned a theorem called the complex conjugate theorem that says if any complex number or imaginary number is a solution, then its conjugate is also a solution, which means that x also equals a positive 5i. Positive 5i is also an answer, okay? So we have those three simple answers. Those answers came from a binomial that was set equal to 0 when we did zero product property. Right? It's kind of like working backwards. So what is the binomial that this answer came from? Don't think about it. Just get it equal to 0 and you'll get the binomial. +3 plus 3, x plus 3 equals 0. Right, here's your binomial that you set equal to 0 to get the answer x equals 3. Over here, plus 5i plus 5i. Right here you have x plus 5i. That's a binomial set equal to 0 that gave you the answer x equals -5i. Which means that the other one, also subtract 5i, subtract 5i. You're going to have x minus 5i as a binomial set equal to 0 that gave you that answer, positive 5i. Are you with me? So it's kind of like working everything backwards. The zero product property is going to unite these, it's going to put them together. So you're going to have x plus 3 times x plus 5i times x minus 5i. Now from here, you have to, I say always distribute or multiply the imaginary values first. The binomials, the blue ones first in this case. Because when you multiply a complex number with its conjugate, the imaginaries will disappear. Check it out. What is x times x? X squared. What is x times -5i? Let's just put it together. -5i with an x. And then positive 5i times x, it's going to be a positive 5i with an x. Then positive 5i times -5i. Positive times a negative is a negative. 5 times 5 is 25. And I times I is I squared. So, as you can see, the middle terms are the exact opposite values. They cancel out. You end up with x squared minus 25 times I squared, which is really -1. So you don't really have a -25, you have a plus 25. So both of those nasty blue binomials multiplied together give you this nice quadratic binomial. Now, of course, we still need to multiply it through with the other binomial that we had over here, the x plus 3. So when we distribute x times x squared, x to the third. X times 25, 25x. 3 times x squared is positive 3x squared. 3 times 25 is 75. The middle values cannot be combined, but you could at least rearrange them to get them in the best standard form. X to the third plus 3x squared plus 25x plus 75. So this is your equation. You could call it f of x if you want. You could set it equal to 0. But that is your equation that if you solved would give you the above three answers. Number 14. Where did the answer -1 come from? From the binomial what? Okay, where did the answer 4 come from? From the binomial what? X minus 4. Right? Where did the answer x equals 3i come from? From x minus 3i. And we know that if you have an imaginary answer, you're going to have also the complex conjugate of that answer there also. So you have another binomial x plus 3i. So what would you begin with? With the i's, right? So if you start distributing here, x times x, x squared, x times 3i is positive 3i with an x. Negative 3i times x is negative 3i with an x. Negative 3i times positive 3i is negative 9i squared. So what we really have here is x squared. These guys cancel, plus 9, because -9 times -1 is a positive 9. So those two blue complex binomials ended up being the quadratic binomial that you see there. Then you'd have to, I would multiply these guys next. and you'd end up with x times x, x squared, x times negative 4x, 1 times x, 1x, 1 times negative 4. Combine these guys, you'll get x squared minus 3x minus 4 as your final trinomial right there. However, we still need to multiply that trinomial times the binomial. I would distribute the binomial into the trinomial. So x squared times x squared, x to the fourth, x squared times negative 3x to the third, x squared times negative 4 is negative 4x squared. And then go 9 times x squared, that's positive 9x squared. 9 times 3x is negative 27x. 9 times negative 4 is negative 36. The only two terms that could combine are the x squared terms. So your final answer will be x to the fourth minus 3x to the third plus 5x squared minus 27x minus 36. That's your answer. Which one's the correct answer? A. Please study this. Guys, this test, I did it multiple choice because it's almost like the final as well. So not only study it for tomorrow's test, but study it for the final.